Hello guys, welcome back to my YouTube channel. So today I have a very interesting topic to discuss which is related to Palo Alto firewall again. So this is going to be a very interesting video. I'm going to discuss zone protection profile here. So I hope you guys might be aware about a zone protection profile which we configure in the Palo Alto firewall. So and you also might have heard about DOS protection profile and DDoS protection profile. So zone protection profile helps you to protect your firewall from this type of attack like DOS and DDoS attacks. So zone protection profile has some more feature. It's an advanced profile where we can protect our network or our server from these type of attacks. So let's begin our video. So I have a Palo Alto firewall. You can see, if you can see my screen, so this is my Palo Alto firewall and I have logged into my Palo Alto firewall. So this is a Palo Alto firewall and this is a dashboard of the Palo Alto firewall. So if you go to the network tab and if you see here the zone protection profile, we have one option, zone protection profile. So here we can configure the zone protection profile. So in order to configure the zone protection profile, what we need to do exactly, we need to add one profile and we have to give it a name. So we can give it any name, like we can give a zone protection profile and whatever the name, it depends on you, so we can give it. And now if you see here, we have multiple flavors here. So if you see here, we have a flood protection, we have a recurrence protection, we have a packet based protection, and so on. So I'm going to discuss all these one by one. So first we will going to discuss flood protection. So if you see here, I am checking the flood protection profile, and in the flood protection also we have multiple options like sync, ICMP, ICMPv6 and UDP. So we will going to configure the flood protection first. Like we will start with the sync attacks. So before moving to the configuration, I would like to give you some summary like why we need to configure this flood protection and what is this sync attacks. So I have taken an example, so a small example. So let's try to understand with the example. So let's suppose I have a one server, application server, which is hosted inside my network, and this is connected to the Palo Alto firewall, and I have allowed the access from the internet, like anyone from the internet can access to my server. So let's take an example. Let's say this is a user, normal user. He is coming from the internet and he wants to access my application server, my server, which is hosted in my network. So in order to establish a connection, in order to access this application server, what he will do, he will try to establish a TCP connection. And I hope you guys are aware about TCP connection. So the first packet he will send it sync packet, because if you know the TCP three-way handshake, so the first packet of three-way handshake is a sync packet. So this normal user will send this sync packet to the server, and server will receive this sync packet. So once the server receive this sync packet, what server will do, server will store this sync packet in its table. So they have some temporary table, and where they can store the allocate some resources for it, and they will store this sync packet here in its table, and they will reserve some memory for this sync packet. Okay, I receive this sync packet, so this request will become the source IP. So because this user is connected to the internet and they might be having some public IP address, so this request will become the source IP. Let's say 1.1.1.1. so this is its public IP, and the server will store, okay, I receive a sync packet from this IP 1.1.1. now what server will do, server will send the acknowledgement, right, of this sync packet. Server will send the acknowledgement of this sync packet and it will send to the client, right? Then the TCP three-way handshake will be completed. Then they will establish a TCP three-way handshake and they will start exchanging the data. So this is how TCP three-way handshake work. I hope you guys are already aware how TCP work. Now let's suppose this is not a normal user. Now let's come to the our main topic, which is a sync attack. Now let's say this is not a normal user, this is a attacker, or you can say this is a hacker machine, right? Now what he will do, he will not send a single sync packet. He will send a 1 lakh or maybe 10 lakh sync packet, 10 lakh sync packet per second to the server. He will not send this sync packet to its machine. What he will do, he will use some other machine. Maybe he will using some he might have compromised some other machine, like maybe from the internet. So from those machine he will launch the attack. He will launch the sync packet. He will send the sync packet, like he will send the request, 110 lakh request per second to the server. Now when this request comes to the server, server will again try to store this information, this sync packet, on its table. Like I received 1 lakh uh, or maybe 10 lakh sync packet. It will try to store this sync packet one by one, and what it will do, it will also try to give the acknowledgement, right? It will try to give the acknowledgement. But this sync packet request is not coming from the legitimate user. It is not coming from the real IP, because the hacker might be using the spoofed IP address. So a spoofed IP address is nothing, but its spoofed IP address is like just some other machine IP address, because hacker might not be using its own public IP address to send this sync packet. He might be using some other IP address, maybe the compromised machine IP address. Let's say hacker might use IP 3.3.3 and 4.4.4. So this request will come from the some other IP address. Now the server, this server will give the acknowledgement to this machine. It will not give the acknowledgement to the real machine, the hacker machine. It will give the acknowledgement to these machine, right? But these machine never send the sync packet, so they will simply discard this packet. So now when server receive this 10 lakhs of packet and it will try to respond to this machine, the server will get choke. Server will get the fully utilized. It will not able to handle the request. Now when the legitimate user, or well the real user, suppose this is a real user, it's a normal user, and he also wants to access the server, then he will send the sync packet. Now the when the traffic come from the real IP, from the legitimate normal users, then this server will not able to handle this request. It will not, it doesn't have any memory to store the sync packet. It will not able to handle this request, and this user will get the error message. He will not able to access the server, so that application, the service will get disturbed, and they will not able to access the server. So this is how TCP sync attack works. I hope you guys now got the idea how TCP sync attack works, how attacker use TCP sync to just down your server. So now we will go into the configuration. So I have already shown you the zone protection profile, how you can configure it. So let me give it a name. I'm giving a name, zone protection profile. Zone protection profile. So remember, when we configure the zone protection profile, we have to configure it on the outside zone, or maybe we can configure it on the VPN zone. But I would recommend you, before configuring this profile, before like mapping this profile on the outside or VPN zone, you can take a look on it. So we will going to discuss this later, but let's start the configuration here. So zone protection, I can give the zone protection here. Now let me enable the sync attack. So if you see here, once you enable the sync attack, you will option here, action, random early drop and sync cookies. Now what are these attacks? Action, random early drops, right? So random early drops and sync cookies. So let's discuss the sync cookies first. So what happened in sync cookies, when the firewall, what firewall will do, when you have a firewall between this source and machine. So let's go back to the topology again. So okay, now we have a firewall, between user, between hacker and the server. So what firewall will do, when the machine will send a TCP sync packet, this request will come to the firewall, right? Now firewall will going to open a connection on behalf of user. Firewall will send this sync packet to the server, because firewall will verify whether this request is coming to the legitimate user or not. This request, then that firewall will send one sync packet to the server, and then server will give acknowledgement to the firewall, and then firewall will give the acknowledgement to the server. So firewall will become the man in the middle type of device. It will act as a man in the middle, and it will help to establish a TCP three-way handshake connection. And if there is a suspicious traffic comes, or if there is a sync attack comes, it will discard the packet. So this is how the sync cookies work. Now random early drop, So most of the time we configure the random early drop. Okay, 1 second. So most of the time we configure the random early drop. This is also recommended by Palo Alto. So most of the time we configure it. So in random early drop, what happen? So we can set alarm rate. So let's suppose again, if I go to the diagram, let me delete this. So what happen? We can set the alarm here on the firewall. We can say okay, like when we receive 1,000 requests or maybe 1 lakh request, 1 lakh sync packet per second here on the firewall or on the server, so just give me some alert. So once we receive this 1 lakh sync packet per second on the server, so firewall, we will set the configuration that we will get an alert here. If you see here, here is showing alarm rate connection per second. So when we get 1, 10, 100,000, when we get 1,000 requests, 1,000 sync packet per second, we will get a alert. So it will get the alert will get triggered. Okay, and the firewall will get active. Now when it will go more than thousands, the configuration will be activated, the sync protection, the flood protection will activated, and it will try to discard the packet after the 10,000, right? Let's suppose if we got a 11,000 sync packet, so it will only response 10,000 packets. It will discard the other packet, like the 1,000 packet, 1,000 packet. So this is how it works. Now if it reached to the 40,000, so maximum is 40,000. If it is reached to the 40,000, like if we received a 40,000 requests per second, it will discard all the sync packet. So this is how it works, right? So let me explain you one more time what happened when we received 10,000 requests. This it will be get triggered, it will be get activated when we request more than, suppose when we increase more than 10,000, when we received 11,000 alerts, so the 1,000 requests will get will get discarded. The 10,000 requests will not get discarded. Okay, so the 1,000 requests will get discarded. But if it reached to maximum 40,000, right, if it reached to the 40,000, then it will discard all the packets, right? It will discard all the packet and it will not reply to any packets. So this is how it works. So let's try to configure it first. Sync packet, sync configuration, then we will do it ICMP. So I'm going to configure it. I'm going to click OK. Okay, now I need to call this zone protection profile on my outside zone. So here I have a zone and I have an outside zone. So yeah, we always configure it from the on the outside zone, because the attack will come mostly from the outside network, right? So I can here call it zone protection profile. Simply call the zone protection and click OK, and I need to commit it. So after committing is the configuration, the zone protection profile will be configured on our firewall, and we will try to launch one attack on our firewall. So what I'm going to do is I'm going to launch attack on my server, application server. So this is my application server. I'll show you the application server. I have hosted one small site here. Okay, so let me quickly log into this. I have a password. Okay, it's not taking the password. Okay, let me try one more time. Okay, so I have hosted one small website here. So this server is having IP address 20.20.20, I believe. I can show you IP config. So it's having IP address 20.1.1.20, but I have configured the destination zone here on the outside zone. So I'll try to access the website from the internet, because you can assume this is my laptop and it's sitting on the internet. So I have just configured zone protection profile here. I can show you the zone DNet destination Z net profile here. So let me show you the destination net as well. So I did some destination net here, and here I define the destination IP address 192.168.1.50. This is my IP address is configured on my outside interface, and the real IP address of the server is 20.1.1.20. So I'll try to access the server, like I'll do HTTP and I'll type the IP address of my outside interface of the Palo Alto firewall. So see, I'm getting this page. Welcome to firewall training classes. So this is my small website which I hosted here, right? So this is responding on port 80. So we will try to launch the attack, and we will try to attack on this server, application server. Okay, the real IP is 192.168.1.50. So let me quickly go to the, so before launching the attack, let me show you the logs here. Currently I'm not getting any logs in threads, right? If you see here, there is no logs in threads, but after implementing the zone protection profile and after launching the attacks, we will start receiving the logs. So let's quickly launch the attack. I have a Kali Linux machine, so this is my Kali Linux machine here. Let me quickly log into this machine, and if I'll go to the root terminal here, okay, I need to enter the password. Okay, this is my password. Okay, now let me try to attack, let me try to launch the TCP sync flood attack. So there is a command hping -c. So it's already taken the command, so I need to replace the IP address because I already tested before this video. I already tested in my environment. So let me do one thing. Let me try to launch the TCP flood attack. There is a command hping, and I will try to send the 10,000 packet, not 1,000. 1,000 will not be enough, so let me try to 10,000 packets. So this is really a length source and port number 80, and I have given the IP address of 192.168.1.50. I hope you remember, this is my server IP. 192.168.1.50 is my public server IP address of my application server IP address. So okay, I think we are good now. I'll try to enter it. So it's started, if you see here, and now will start receiving the logs here in the firewall. So let's wait, it will show you the logs here. You will get now the TCP flood attacks, and your firewall will protect you. Okay, it's still not coming, so I think we need to wait it. The attack is still running. Okay, HP mode, no replies is shown. Okay, I think the commit config, the commit is still not okay. The commit has been completed, but strange, we are not receiving the logs. Yeah, now it's coming. See, TCP flood outsides coming from the outside zone, and see, you will not see the source IP because I am using a Kali Linux machine, right? So it hide my IP address. You will not able to see the source IP address. If you see here, random early drop, because I configured the random early drop. If you remember, if I'll go to the network tab here, zone protection profile, in zone protection profile, I'll show you the random early drop, right? So we configure the random early drop action. So after getting a 10,000 packet, it will discard the other packet. So one second, let me go to the logs again. So here, see, now first it gave me the error, then it didn't dropped it just gave me the error because it's reached to the 10,000. After 10,000 it start showing me the packet. Okay, it start dropping the packet, right? So let's do one thing, let's try to send some more packets, like instead of 10,000, let me send 20,000, right? And you will see here it will start dropping the packets. So after 10,000 it will only handle the 10,000 requests. After 10,000, it will drop the other packets, the 10,000 packet it will drop it. But if it reaches to the 40,000, it will drop everything. It will drop the rest of 10,000, and it will also drop the 30,000. It will drop everything if it is reached to 40,000. So see, now I'm getting the logs, TCP flood, TCP flood. See, it's not dropping TCP flood, it's saying random drop, but we will see the drop message as well here. So we have to wait it and see, flood, PAB flood, PAB packet drop. Now it's coming from the source IP 192.168.1.20, and start dropping the packet. Okay, so let me check if my Kali Linux machine is having the same IP address. So if I'll do Control C, yeah, ideally it should not show my IP address, but it's still showing my IP address. So yeah, so the hacker, what it will do, it will like spoof the IP address. So sometimes see, it's not showing the IP address when it's coming to the TCP floods, but it's coming when we are coming the drop packet, it's showing the IP address also. So this was the like live environment. It was I already shown you how to like prevent from these type of attacks, right? So this is how you can prevent from these types of attack, especially when it comes to the DDoS attack or DOS attack or TCP sync flood attack. So this is all in this video. uh, we will make another video for ICMP flood attack. I hope you receive some information here. So just try to do it in your environment as well. Try to configure it if you have a EVNG, or if you have your lab, try to configure it and try to launch the attack from Kali Linux. You can install the Kali Linux and you can just try to launch the attacks. So simply you need to give this command, and whatever the IP address you is using, you can give it. So let me also launch the ICMP flood attack. So I haven't configured the ICMP profile. Let's do one thing, let's configure the ICMP flooded as well. Just you need to enable it, right, and click OK. Just do the commit, and we will launch ICMP attacks as well from the Kali Linux. So if you see here, I am not receiving any ICMP attacks here. I am only getting the TCP flood. So once I launch the ICMP attack, I will get the ICMP flood logs here. So as of now I am not getting it, but yeah, once I launched, I will see the ICMP flood attacks as well. So let's wait. Once the commit process completed, we will try to launch the ICMP flood attacks from the Kali Linux only. So in order to launch the ICMP attacks, we have the same command hping 3 -c. We will send 20,000 packets, and we need to give the random, I think, random source -1. Target IP we need to give 192.168.150 and hyphen flood. Okay, let's see. Still the commit process is not okay. This command is not valid. I think I missed to give h. Okay, I need to give hping t3. Okay, hping e random source. Yeah, so this is a valid command. So let's commit process completed, then we will launch the attack. Okay, so still the commit process is not completed. It's only 55%. So once it is completed, we will try to launch the attack. 98% completed. So as of now you can see I'm not getting any ICMP flood attacks. So after launching the attacks, we will get the ICMP flood logs as well. So in ICMP flood, what hacker will do, hacker will not send the sync packet, but it will send the ICMP packet, the echo packet. I hope you might aware about the ICMP, right? So in a ICMP, the first packet is a ICMP echo packet, right? So what hacker will do, hacker will not send the ICMP packet, it will send the hacker will not send the sync packet, it will send the ICMP echo request to the server, and the server will store this echo request. Again it will do the same thing, and it will try to give the reply of the echo, but the request will not come from the actual server IP. It will come from the like spoofed IP address, and it will give the acknowledgement, it will give the reply to the spoofed machine, but that machine will not able to reply because they never send the echo request, right? So it's the same kind of attack, but instead of sync, it will use the ICMP, right? So now let's go to the firewall. Okay, now try to launch it. It's completed. Now try to launch ICMP attacks. Okay, now let's try to refresh this page. Okay, it's still not coming. It will take some time, I believe. Okay, it's still refreshing. Let's wait for few minutes, then we will soon get the logs. So this is how your Palo Alto firewall will protect. So if the network engineer configure the zone protection profile, it will very helpful. It will prevent you from these types of attacks. So I would definitely suggest you guys to configure it zone protection profile. But before configuring it, I would also recommend you to like reach out to tag Palo Alto tag, or maybe check with your management whether it needs to configure or not, because I have also seen a scenario where you might face a issue after configuring this profile. If you configure it on VPN zone, if you are using a global protect VPN, and if you have configured this profile on VPN zone or outside zone, so you might face a lot of challenges, right? User won't be able to connect VPN after configuring this profile. So you have to be very careful before configuring this profile. You have to test it before in your environment, in your lab environment, then only you can configure it, right? So that's would be a good practice. So I am still not getting any TCP attacks. Okay, I think I need to refresh this page sometime. It because this is a lab environment, so sometime it takes time. So or I can do one thing, I can launch the attacks one more time. Let's do control C and try launch the attack. Okay, see my firewall, oh my firewall utilization may get high, that's the reason. So I also missed you to inform you, like once we get this type of attack, my firewall CPU utilization will also get high, so I need to like close this attack. Yeah, so now you I think might get a better idea. So this is a like live attack happen here on the firewall. So this is how attacker can attack on your firewall. So what happened here, my firewall utilization reached to 100%, or maybe more than 100%. The management or CPU utilization reached to 100%. That's the reason firewall won't be able to handle it, and firewall won't be able to respond it. That's why I'm not able to log in. I will show you. It will take some time, because or maybe I need to clear some session on the firewall. Let's see if I'm able to access it from the CLI. Okay, now I am able to login. So this can be happen. So if someone launch the ICMP attack or sync attack on the firewall, when the firewall receive this type of packet, firewall will also not able to handle this type of, because what happened, I send here 40,000 packet, right, and sync packet, and then I send ICMP packet, right? So let me show you the firewall utilization, the CPU utilization. You will see it will go 33%, right? If I launch the attack one more time, see, let me show you one more time. So if I launch the attack, it will again reach to the 100%. See, let me refresh the firewall. See, it's reached 35%. Okay, let me stop it, then I'll show you, because it will continue to send the packets. See, it's reaching management CPU to 35%. Then again firewall, see, it's reached to 47%. Management CPU is reaching 47%. And if I launch the attack again, it will reach the 100%. If I launch the attack again and just refresh it, it will reach to 90 or 100%. Let me cancel this, then I'll show you. Still 47%. Let's try to send some more packet, like instead of 20,000, let me send 1,000. Otherwise my firewall will get fully utilized, and it will not able to access, we won't be able to access it. See, it's reached to 47%. Let me refresh it. Okay, and 39%. Let's send some packet. Let's wait for a few seconds. I think it will go to more than 50% or more than 90%. If I'll send more packet, then it will definitely reach to 100%. if I'll send 1 lakh packet, let's see what happen if I'll send a 10 lakh packets, 1 lakh packets. So this is not a like this firewall is not in production, so it will not impact anything because it's just for a lab environment. So we can send like 1 lakh packets also. Let's see what happen. Let me refresh it. And see, the session is also increasing 226, right? So it will continue increase. So the firewall is still not responding, right? See, it's reached to 87%. So this is how the attacker use this type of attack to you, uh, to just drop your firewall memory utilization or to down your firewall. Now let's also see the logs in the monitor, whether I'm getting any logs in the threat. I should get the logs in threat as well. ICMP flood. See, I hope it's clear for you. See, I'm getting ICMP flood, random early drop, right? If you see here, I'm getting a ICMP flood attack. It's coming from outside. It's not showing the IP address. Ideally, it should not show you the IP address, the source IP address, because I'm using a Kali Linux machine. You will not get an attacker IP address. So this is how attack works. So I hope you guys get an idea how TCP sync attack and TCP ICMP attack work, and how your firewall get utilized 100%, your CPU utilization get high. See, data plane is also getting high, 70%. Session count is just 3 and you get 70% utilization. Because I just stopped the attack, that's the reason it decreases the CPU utilization and reduced to 15%, and data plane is getting 70%. If I launch the attack for 5 minutes, my firewall will get fully utilized and I won't be able to access it. So this is how attack works, right? So I hope you guys got an idea, and this is it. And we will try to make another video for another reconnaissance protection, and we will discuss another profile, like we have UDP. We will do it UDP, and we will also configure the reconnaissance protection in the next video. Thanks for watching this video.